Okay, we got a lesson on the antiderivative. Okay, so the antiderivative, well, with derivatives, you're taking a function, you take its derivative, you take its second derivative, you're finding its slope, you're finding its velocity, you're finding its acceleration. Well, what if I was going backwards? Okay, so I start with acceleration, the second derivative. Maybe I want to go back to the first derivative. And maybe I want to go back to what the original function was. And I can go back one further, and we're going to, notation-wise, that's going to be a capital F of x. Okay, so it's the antiderivative is opposite of doing the derivative. So let's take a simple example here. Function equals x squared. F of x equals x squared. We have a little quadratic here. If I was to do the derivative of it, okay, bring my exponent down, reduce the exponent by 1. Well, to do the antiderivative, I got to do the exact opposite of that. So instead of reducing the exponent by 1, I want to increase the exponent by 1. Okay? And then I need to divide, instead of multiplying by the exponent for the derivative, I'm going to divide this time, and I'm going to divide, I'll do 1/3, by the raised exponent. So before, you brought the exponent, for doing the derivative, I brought the exponent down, increased the exponent by 1. For doing the antiderivative, I'm going to raise the exponent and divide by the raised exponent. Okay? Now one thing, sometimes you might have a constant, and when you take the derivative of a constant, it goes to 0. So you might have a constant here afterwards that I don't know about. So I need to put in a plus c, because there could have been a number in there, and when I took the derivative, it went to 0. Okay. So here's another example. I have a function 3x squared plus 2x minus 1. If I was to do the derivative of this, I reduce the exponent and multiply. So I bring the exponent down, multiply, reduce the exponent by 1. Bring the exponent down, multiply, reduce the exponent by 1. Just give me a 2. And then my -1 constant goes to 0. Well, do the antiderivative, I'm going to increase the exponent, and I'm going to divide by the increased exponent. So I'm going to be dividing by, so I had 3x squared, well, it's going to become 3 over 3, x cubed, plus, and then I had a 2x, was going to become a 2x squared by increasing my exponent, divided by my increased exponent. Minus 1, okay, I want to add an x onto that by increasing the exponent, and divide by my increased exponent, and then I have my unknown constant that I could have had there that would have went to 0 into the derivative. Now I can reduce these fractions, okay, 3 over 3 becomes 1, so it becomes just x cubed. 2 divided by 2 is just going to be x squared minus x plus c. Okay? Now what's this useful doing the antiderivative? It's going to be useful in doing something that's going to be called finding the integral or integration, or also useful in finding the area under the curve. Okay? And we'll get into a later video into the fundamental theorem of calculus in finding the area under the curve. Notation wise, you have a great big long squiggly s, okay, and that's going to tell me to find the integration of my function dx, and that means find the antiderivative, capital F, okay. So notation wise, you're going to have this, the squiggly x, your function dx, these are the notation. That means to find that antiderivative. So for example, okay, squiggly x, function dx, this is telling me to find the antiderivative, to integrate this function. So I'm going to do so by raising my exponent, so it becomes an x cubed, and so I have 3x cubed, divide by my increased exponent. 2x, raise the exponent, divide by the increased exponent, plus c, okay, for that unknown constant. And then I can reduce my fractions to become just x cubed plus x squared plus c. Okay? Formula for a simple term, if you want to, for any individual term, if you want to integrate any individual term, you raise your exponent. So as n becomes n plus 1, divide by that raised exponent plus c. Okay? So a simple little lesson on introducing the antiderivative. Notation-wise, it is a capital F function, and sometimes you might see the squiggly s telling you to integrate or to find the antiderivative of that. Okay, thank you very much.